Okay, today I'm going to teach you about radicals involving variables. So we got this expression that includes variables. So what I do is I break this up into multiple. So the 16 is going to get its own square root. X to the 5th gets its own square root. Y to the 7th gets its own square root. So look at 16, perfect square. It's 4, be plus or minus. Okay. Now you're like, well, how? Nobody's ever seen how to do a variable though. So the square root of x to the 5th. You're like, how the heck do you figure that out? Well, here's how. You're not going to write this. There's an easy way to do it mentally. First off, we all know that x to the 5th is x times x times x times x times x. Now what I can do is write 5x's, and I can break up the square root so that it covers 2 of them at a time, and then this one would be left without. So this ends up being the square root of x squared, the square root of x squared, and that's just square root x. Well, the second and square root cancel, and that's just going to be x times x, okay? That will not cancel because there's no second power, so that x stays in its square root. So that would be x to the 2nd times the square root of x. So again, x to the 5th, I break it up into 5x's, and I can also break up the square root so it only it's got to cover everything, but I can make multiple square roots. I'm allowed to do that. So I'm going to square root 2 at a time until I get one that can't have another one. And those cancel. So it gives me 2 free x's. So x squared and x. Now here's the best way to do this in your head. A square root means 2 at a time, okay? If I have 5 people, how many groups of 2 can we get? We can have 2. It's like they have to break out of jail, but they have to break out in pairs. There could be 2 groups. How many would be left? 1. Okay, now if I had 7 people, how many pairs can you get out of 7? 3. So y to the 3rd, and then y. Okay? So here's what I do. I make my square root. Now that 4 is outside the square root, plus or minus 4. Okay? And then x second is outside, and then x is inside. You're getting as much of this expression out as you can. Y to the 3rd's outside, and y is inside. Okay, so that's we have. Okay, next problem, another square root. So square root 20, square root x to the 11th, and square root y to the 5th. Now it's a square root, remember, so perfect squares. Okay. So what can 20 divide by? It's not a perfect square, but it divides by 4. That's 5. So that's 2 square root 5, plus or minus, okay, because it's square root. Now, if you have 11 x's and you're grouping them by 2's, how many groups of 2 can you get? You can get 5, and there's 1 left over. You need to put x to the 5th, though, not just 5. Okay, if I got 5 y's, how many groups of 2 can I get? I can get 2, so y to the 2nd, and there'd be a y left. Okay. Okay, so my answer, I put plus or minus 2 out here. I'm going to leave the 5 in the square root. I'm going to put the x to the 5th out here. And then that x that we had left over is still in the square root. That couldn't break out of jail. Y to the 2nd. And then there's still a y rotting in jail. Okay. The jail thing is about the best analogy I could come up with. Now the next one is a cubed root. Okay. It's the same idea. So I break it up. So I'm going to have the cubed root of 108. I'm going to have the cubed root of x to the 7th. I'm going to have the cubed root of y to the 9th. And the cubed root of z to the 13th. Okay. So let's go to town on this. Now you're not looking at squares anymore. You're looking at cubes. Okay. 108's not on the list. It doesn't divide by 64. Let's see if it divides by 27. So 108 divided by 27. It does. It's 4. So the number I found was 27. And then I divide that by 27. I get 4. Now we need to eliminate that because the cube root of 27 is equivalent to 3. But it's not plus or minus because cubes can only be the positive. Now let's talk x to the 7th. So the cube root of x 7th. Now don't write this down, I'm just illustrating. I break that into 7 separate x's, but now I put a cube root over 3 of them at a time. So that's a cube root of x to the 3rd. That cancels. That's a cube root of x to the 3rd. That cancels. So 2 x's are free. And this x here is still in the cubed root. It does not cancel. So x squared, then cubed root x. Now here's the easy way to do it. Now they have to break out in 3s. How many groups of 3 or 3s can you get out of 7? I think you can get 2 with 1 left. How many groups of 3 you get out of 9? You get 3 and there's no left, okay? I'm able to get a nice round number of 3s, so I don't need, or yeah, actually I'll leave that. There just won't be anything inside. Okay, how many 3s can I get out of 13? Well, 3, 6, 9, 12, so 4. There is 1 left though. Okay, so 3 goes out and 4 goes in. X squared goes out and x goes in because that one's still in jail. Y3's out and there's no y's sitting in the square root. So z fourth out and z in. Okay, now it's a cubed root, so try to fit a little 3 in there to tell your audience that's a cubed root. Okay, next, now we're at 4th roots, all the same kind of principle. So 4th root of 96, 4th root of x to the 10th, the 4th root of y to the 7th, and the 4th root of z to the 4th. Okay, so 96. 96, not a perfect 4th. It's not divisible by 81. Let's see if it is by 16. Yep, 16 and 6, okay. Okay, remember, now this is not 4. You got to be careful on that because the 4th root of 16 is 2. Okay, so it's 2, not 4. Now, if the x's have to break out in groups of 4, you got one, you can have 2 groups because that'd be 8 total x's, and then there'd be 2 left. Okay. How many groups of 4 you get out of 7? How many teams of 4? You can just get 1. So if there's 1, just put y. Don't put the number 1. You'd have 3 left in the jail. Okay, if I have 4 z's, I can get 1 group out, and there wouldn't be any left. So cool. Okay, and by the way, it's a 4th root, so it's plus minus. So plus or minus 2's going out, 6 is in. X squared out, and there's 2 more x's in. Y goes out, and Y3 goes in. And then Z is out, and there are no Z's left. So they break out in groups. Those left without the group stay in the square root. Okay, now I got 2 more. Actually, yeah, there's like one weird one in here. I can't remember which one it was. Okay, so cubed root of 320, cubed root x 6th, cubed root of y to the 9th, and the cubed root of z to the 2nd, okay? Okay, now we're looking at cubes. You have to know what list you're looking at. You get caught looking at the wrong list, you're screwed. So 320. Okay, you'd have to go for a while. He doesn't divide it. Eventually divides by 64. So 320 divided by 64 is 5. Now, again, that's not 8 because you're on cubes, not squares, so cubes. The cube root of 64 is equal to 4, so this becomes 4. Just positive. Cubes are only positive. Cube roots, the results. Okay, so if I have 6 x's and we're breaking them out in groups of 3, how many groups is that? There's 2, and they're all out. Okay, you don't need any x's under there. If we're breaking the y's out in groups of 3, there's going to be 3 groups of 3, none left. Now I have 2 z's. I can't get even one full group of 3 if I only have 2, so guess what? You sit in jail. Okay, so 4's out. 4's out, 5's in. Okay. X squared out. We're not going to have any x's left. Y3's out. And Z second is in. Okay. Rotten. Okay. I'm actually going to do one. I'm only going to have you do the odds on the assignment. Okay. Because this isn't all that fun. Really, it's not. Okay, fourth roots. 80 not on the list. Let's see if 80 is divisible by 16. Okay. It is. So 16, 5. Okay. Now it's not 4 though, because it's a fourth root. The fourth root of 16 is equal to 2. Plus or minus, because it's a fourth. Okay, if you're breaking them out in groups of 4, you can get 3 groups of 12, or 3 groups of 4 out of 12. There wouldn't be any left. Now, I can't even get a full group out of that, so those y to the third remains the same. Okay, I can get 2 groups of 4 on the z's, and there'd be 2 left over without a group. Okay. Okay, so 2 and 6. Or 2 and 5, sorry, 2 and 5. 2's out, 5's in, plus or minus though. X3 out. Y3 is in. And then I'd have Z to the second power out and Z to the second power in. Okay. Now on the assignment, you're going to do the odds, and I'm even going to do number 3 with you. All I need you to do is the odds. Fourth root of 17, the fourth root of x to the 9th, and the fourth root of x to the 12th. So 17, is that a perfect fourth? No, and 17 doesn't divide by anything other than 1. So it's a prime root, okay? So if I'm breaking them out by 4s, I get 2 full groups, and there'd be 1 remaining. Out of 12 y's, I'd get 3 full groups, none remaining. Okay, so 17 remains in prison. Okay, all of it. So x second and x, and then y third out. There would be no y's in. Okay.